In this section, we want to look at the method of elimination. It presents another technique for solving a system of linear equations. You're probably familiar with it. The key step is to obtain for one of the variables coefficients that differ only in sign so that adding the equations eliminates the variables. The method of elimination. Obtain coefficients for x or y that differ only in sign by multiplying all terms of 1. Add the equations to eliminate one variable and solve the resulting equation. Back substitute to solve for the other variable and check your solution. I hope you remember how to do this from doing this in some of your high school classes, but let's do some examples. How about 3x minus 5y equals 2? Notice in that system, all we have to do is add the two equations together and we've eliminated the y's. 5x equals 15, x equals 3. We back substitute and we get that y is 7/5. So our solution is 3 7/5. Let's look at another system. Alright, we have 2x plus 3y equals 18, 5x minus y equals 11. Alright, looks like if we will multiply the second equation by 3, we ought to be able to add it to the first one and eliminate the y's. Notice elimination. We get 17x equals 51, x equals 3. So we have 2 times 3. We back substitute. 3y equals 6. Oh yes, subtract 6 from both sides, and we get 3, 4. Now, 3r plus 2s equals 10. 2r plus 5s equals 3. Now, this is one of those where we're going to have to multiply both equations by something to be able to eliminate. So, let's multiply the first equation by 2 and the second equation by minus 3. Let's add them together. Minus 11s equals 11, s equals minus 1. So now we do our back substitution. 3r plus 2 times minus 1 equals 10. We get 3r equals 8. r equals 8/3. Uh-oh, I see a mistake. 2 times minus 1 does not equal 2. So let's get a different colored chalk here so that we can go through and fix the error. So we get a minus 2, we add 2 to both sides, get 12, get r equals 4. See, sometimes even the teacher makes a mistake, and we have to correct it. We get 4 minus 1 as the solution. So, two systems of linear equations are called equivalent. There are certain things you can do to them. For example, you can interchange two equations. When you interchange two equations, you don't change anything but the looks. We can change looks, we just can't change what they equal. So for example, we've got x plus 5y equals 10, 3x minus 5y equals minus 5. Let's interchange the two equations, which just means write the second one first and the first one second. And notice these are going to be equivalent. That means that if we were to solve either one of those systems, we'd have the same answer or the same solution. All right, we looked at interchanging two equations. We can also multiply one of the equations by a non-zero constant. And all that it'll do is change the looks. It won't change the final answer. All right, let's look at our system here. X plus 5y equals 10. 3x minus 10y equals minus 5. So let's multiply equation 1 by 2. Getting plus 10y equals 20. 3x minus 10y equals minus 5. All right, in this case, these are equivalent systems. They will have the same solution if we went ahead and solved them with elimination. All right, now we've looked at interchanging two equations, multiplying one of the equations by a non-zero constant, and the third thing we can do is add a multiple of one of the equations to any of the other equations in the system. We'll still get the same solution. We'll have an equivalent system. All right, right? We're using the same system of equations. So we're going to multiply equation 1 by 2. We're going to add it to equation 2. Then when we combine them, notice that the y's were eliminated. And this is the same solution for x as we would have gotten with x plus 5y equals 10. Now, we'll do some back substitution. We get 5y equals 7 and y equals 7/5. We're going to go ahead and finish this system this time. So what have we done here? We multiplied one equation by a constant and added it to the other equation.